Hi folks, so the question we have in front of us today, guys, is question 6. It's in the World of Graphics textbook, page 250, on the topic of developments, okay? And we can see the image here, guys. It's based on a hexagonal based prism. So obviously a hexagon at the top, a hexagon at the bottom, and we know with a hexagon it's 6 sides, okay, all of equal length, and then various angles on the internal and external angles. And what it's asking us to do is, it says a regular hexagonal prism is shown below. Draw a plan in the direction of arrow A, so the bird's eye view. So we'll just see this top surface here. An elevation projected from the plan in the direction of arrow B, so an elevation over it, and then complete surface development of the prism. Okay, so obviously there's a top, there's a bottom, and we've actually got 6 sides that are all kind of rectangular shaped as well, and they'll all be the same. We can see one of the lengths of the sides here is 30, and then the height of it is 70. Okay, so we're going to start that there now, and we're actually going to start off by doing the plan view first. Okay, so just zoom out there, and as you can see, guys, I've kept this my XY line to the left of my page, and I'm going to do my surface development on the right hand side of my page. So starting off, I am going to do a hexagon, okay, in my plan view. Now we know that one side has a length of 30 millimeters. So I'm going to start off there by doing a line of 30 millimeters right here. Okay, so 10, 20, 30, right there, just like that. Okay, so I've marked 30 there, and I'm going to heavy that in just to have it done. So that is one side of my hexagon. Now, anytime we're dealing with a hexagon, okay, we have to think of a hexagon inside a circle, and what we're going to do is we're going to divide the number of sides, which is 6, into the number of degrees in a circle. 360 divided by the number of sides is 6. Okay, 360 divided by 6 is equal to 60 degrees. Therefore, the exterior angle on your hexagon is always going to be 60 degrees. So at this point, what I'm going to do, 60 degrees, I'm going to project down at 60 degrees for the hexagon, and also 60 degrees down here like this. And we know that the length of the sides are 30 millimeters. So I can measure down there. I'll actually do it on this one. Measure down 30 millimeters, mark it off. And since I've it marked on this side, it's very, very easy then. Instead of actually measuring it again, you can see I have to extend my line. But I could just do a line across like that and extend it down to meters. Okay, now from this point and this point, I can also go at 60 degrees down, and then the exact same from this one. Now there's a couple of ways you could do this. I could once again measure 30 millimeters like that, and then where it hits here, just do a line across, or from the top I can come straight down. Okay, regular hexagon, from there mark it down, and then from here project across, and there we go, we have our hexagon in our plan view. Just going to heavy that in now. Now if we think of polygons, because that's what it is, okay, if we think of a pentagon, which often comes up, okay, in the junior cert syllabus, pentagon, if we divide the number of sides, pentagon has 5 sides into 360. That would mean that the exterior angle of a pentagon is 72 degrees. 360 divided by 5 is 72, and you can keep doing that if you wanted to go on to a 7-sided polygon, a heptagon, divided by 7. 8 octagon would work out being 45, and so forth. Okay, so basically what it means is the exterior angle, okay, so that's why I left these lines out here, but the angle in here is 60 degrees, like that. Okay, exterior angle 60, the interior is 120. Once again, 60 degrees here. If I was to continue this line on, just to show you there, so from the edge, if I was to continue that line on, we know that that angle, exterior angle, is 60 degrees. Okay, so there's our hexagon done in plan view. Now what we're going to do is we're going to project that up to our elevation. Okay, the front projects up, probably went a bit high there, don't need to go that high. You can see they're all matching up. and then we know we have a height of 70 millimeters. So mark up my 70, and then my lines across. Because in our elevation you have to imagine we're looking in this direction, so I'd see all of this face here, which in this view, in the plan view, we see it as an edge, and I'd see a bit of this face, and I'd see this face as well, okay? I'm not seeing the true shape of them though, okay? So there we have it, that is it in our elevation, so we're just going to heavy that in. Nice and easy. There we have it. Elevation and plan views completed. Now, working out the number of sides, as I said previously, we know we have 6 faces, okay, the front, the back, the side, another side, and another side. So 6 faces are all going to roll out together because they're all connected, and then we have a top and a bottom that both have the shape of a hexagon. So the easiest way to do this surface development is project across, okay, my heights that I already have for my elevation. And I know each one of these faces is 30 millimeters long, okay? So 30 millimeters and 6 faces, 30 times 6 is 180 millimeters. So I'm going to mark that off there, and I'm going to go in gaps of 30 millimeters. 30, 60, 90, 120, 150, 180. Nice and simple there. I'm going to mark all of those lines up. Start with this one. I'll go out to the end one as well. And I know these all fold back together, so what I'm actually going to do is, at my ends, I know they're actually going to cap off, so I'm going to put them in heavy. And all those 30 millimeter marks, okay, because each face is individual, I'm going to do a hatched line, okay, like that, because they are our fold lines. Fold line here, okay. If you're doing this in an exam, you probably take a little bit more care over your hatch lines, okay? Make them a little bit neater than I'm making mine currently. And finally, this one. So there's all our fold lines, okay? So face 1, 2, 3, 4, 5, 6, okay? 6 faces done. Now we know we have the top and the bottom. And the top I'm going to attach on obviously up here, and the bottom I'm going to have on down here. And essentially all I'm doing is I'm replicating this hexagon here, okay, above and below. Now it's my choice, guys. You could actually put it here, you could connect it onto this face, every one of them will actually work out. To keep it nice and even, I'm just going to do the same, and I'm going to pick a face to do it on both top and bottom, okay. So I'll actually do it in one of the middle faces, and I'm going to do it off of this one here, okay. So we know, once again, it's at 60 degrees. We've already gone at 30 millimeters. So 60, 60, very quickly I'm going to measure down 30 millimeters. There's my 30. Mark that across to the opposite side. You can do that lightly, and then once again 60 degrees and 60 degrees. And once again, I know where the 30 is here, so I could bring that down, just mark it there, project across. And there we have it. There's my hexagon in the bottom of it. Exact same for the top, so I'm going to do it up here within this gap. So 60 degrees up, 60 degrees the other way. Okay. To find exactly where that mark is, I have it already done here. So from the outside of it down here, my hexagon, I'm just going to literally, I'm not going to do a line the whole way up, just going to mark it up there. Okay, do the exact same with the opposite side, mark it as well. Okay, and once again, 60 degrees up and 60 degrees up. And very, very easy at this point now. From here, mark that there because it's in line with this 30 millimeters, and finally project that out there. So there we go, we have the top and the bottom. So it's literally a case now of heavying that in. So I'm just going to speed up the video there now. So there we have it, folks. That is the surface development of a hexagonal base prism, and we can see there we have the top surface now and the bottom surface put in, and as you'll see there I also put in the fold lines of where they attach on. So that line there could not be heavy the whole way because it has to be attached on in some way. Now another way you could do this question is I technically could have put the bottom attached onto this one, and I could have attached the top onto this one, because it all would have folded back the same way as well. Okay, there's a couple of ways, as I said, you could do it, but that way there is probably just, I think, the neatest and the tightest. Okay, hope you found that helpful, guys. That is the question complete there. Okay. Hi folks, so the next question we're moving on to, guys, is over the next page on page 251, and it is on question 8. The question says a trampoline based on a regular hexagon is shown below. Okay, so we can see the regular hexagon here. It says draw a plan in the direction of arrow A, so looking down top of it, a bird's eye view, so we'll see the hexagon, and then an elevation projected from the plan in the direction of arrow B. So we are also going to draw what it looks like, the front view of it looking in the direction of arrow B, in this direction here. So we'll see this face a little bit here, and this face. We wouldn't see the back three faces though. Okay, and obviously we'll see the hexagon as a line when we look straight at it. And then part C, the complete surface development of the trampoline. So we're going to fold it out and then include the diagonal supports in the elevation and development. So they're asking us to include these diagonal supports here, joining from corner to corner of each face. Okay. Just the reason I've done this question, guys, is I'm just showing you it's another prism. It's essentially the exact same as the last question, only the face lengths, okay, are different. They're longer. In the last question they were 30, and this one they're 44. And the height in the last question was 70, and in this question it's 36, so it's a bit shorter. So it's a very similar question, but the reason I want to do it is I'm going to show you another way that we can actually develop it out. And in this case also, we don't have a top surface, okay? Because if you think if it's a trampoline, you have to be able to bounce up and down. We do not have a top surface here, so we just have the hexagon. We just have the hexagon at the bottom, okay? And then we have the 6 faces on the outside, okay? So I'm going to start that question there now, guys. So just zoom out there. Going to keep it once again to the left of my page. So I'm going to put in an XY line. Like that, XY, and then I'm going to do my first line here, and I'm going to make it 44 millimeters. 44 millimeters. Just make sure it was 44. Yep, 44. And from there, 60 degrees down to the left. 60 degrees down to the right, as previously explained. Okay, the exact same thing, only this time I'm going to take the lengths on my compass, just showing you another way. So 44 that way, didn't reach it there. Let's see if it reaches here. Just about reaches there, happy with that. So that's just another way you could do it there, guys. So I'm going to heavy these in now, from there to there. There to there. That's the top half of my hexagon done. Okay, now I'm going to do the bottom half. So same method. 60 degrees down. And I could either mark it up from the top here, marking it there like that, or I could have just taken the 44 originally, marked it as well, same position, and there we have it. There is our hexagon in our plan view. Okay, that is what you would see of the trampoline, as they're calling it in this case. And what we're going to do now is we're going to project up an elevation using our plan view to guide us. So from the plan, I'm going to mark up, switch out my set square there, project up I should say. It comes up to a height of 36, so I think that'll be enough. These two will match up. Same with the next two, and finally last one. And check my height there, mark up 36 millimeters. There's my 36, and do a line across. So keep this neat and tidy. Heavy line all the way across. and heavy line down, because this is where the supports would be, okay, the railings. And then they also said they want us to put in the diagonal supports, okay. So in relation to the front face, that would be like this. Side face, you would see it, you just see it as a skewed version, okay, kind of a shortened version. And then the other side face, think of it as a door opening and closing. Okay, so there we have it. Front face, the side, and obviously there's the back, and then the other sides as well. So the reason I've actually done this, guys, now is I want to actually do the development a little bit differently to last time, okay? Probably a little bit of a harder way, okay? Probably going to be a little bit more time consuming. It would be very easy to fold out the 6 faces, 6 times 44, like we did in the last question, and just do them out like that, and then attach the hexagon at the bottom. Okay, in this case I'm actually going to do the hexagon first, and I'm going to attach all the faces as if they've kind of folded down off it. Okay, so once again, I'm going to draw this exact hexagon. Okay, and I'm actually going to keep it roughly, you can start this anywhere, I'm going to keep it roughly in here in the middle. So once again, 44 millimeters, I'm going to mark that 44. Okay, down at 60 degrees. Degrees down, and once again I'm going to mark that 44 on my compass, take it there, mark it out, just had enough, left that one a little bit short, and from those 2 points once again at 60 degrees, 60, and from this one here 60. Finally, once again, mark my 44, still have the exact same length on the compass. There we have our base, okay? We can see our base there, and that is technically where the spring part of the trampoline is. Now, as I said previously, I could have done the 6 sides, okay, all attached on up here, and then the bottom just attached onto it, okay? However, this time what I'm actually going to do is I'm doing the base, and if you imagine that was one of these faces obviously is coming up, okay, I'm actually just going to fold it down. Same here, it comes up, and I'm going to fold it down, up, fold it down, vice versa, folds down, folds down, fold down, okay. So technically all those faces are actually rectangles that are 44 long but 36 high, and they're going to come out perpendicular from here. So if I just do the top one, that's probably the easiest one to explain it, okay. Technically, I'd have a face that comes up like this, but I'm going to basically fold it down flat. So, all I'm going to do is I'm creating perpendicular angles. Okay? So, very, very simple. And the bottom would be the exact same, actually. I might as well do 2 for the price of 1. So, bottom would be the exact same. And we know that the overall height of it is 36 millimeters, so I could measure that in, just to have it done. So, there's my 36 on the way down at the bottom. Just to have it done. Okay, and I'll mark up the 36 on the top as well. So there's my 36 at the top, and that is 2 of the faces technically done. Okay, so just heavy those in, just to give you a guide of kind of how it really does look. So I'll heavy that in. I'm going to heavy this in, and I'll explain why I'm getting these bits in heavy. Heavy this one. Going to heavy in this bit here. Where anything attaches on, we know there's meant to be a folds line. Okay, so if you think of the 6 faces, I've done 2 of them. I have another 4 to go. I've done this face and I've done this face. I have another 4 to go. I'm going to have 1 here, 1 here, 1 here, and 1 here. But where they attach on is at the trampoline. So technically, my hexagon, in this case, last time I had a fully dark hexagon. This time, all the lines of my hexagon are actually going to be my folds lines. Okay, so I have a fold line there. I'll do this one as well. Fold line here. Okay, I'm going to have a fold line here, because I know there's going to be another face attached onto this. Okay, a fold line here. Okay, fold line and fold line. Alright, so there we have it, guys. That is kind of one of the faces that stands up. If you imagine if I was to cut this out of a piece of paper and just fold it back upwards like that, and the same with this one, okay, and it would fold up like that as well. Okay, now also they told us we have to put in the diagonal supports, so I'll just get those in. Okay, because it helps us with our visualization. So that's the faces. And in this case, we will see all the diagonal supports like this. Now, we have kind of about 60% of the development done. We have this face, this face, this face, and this face to do. Okay, so what we want to do is we want to create perpendicular angles. Okay, because if you think this line was perfectly horizontal, this line was perfectly vertical. Therefore, the angle created between the two of them where they meet is actually a 90-degree angle. So, the way I always say it in class is, if this angle is 60 degrees, 60 plus what makes 90. Okay, so 60 plus what makes 90. A little bit of maths, 60 plus 30 makes 90. So therefore, to create a perpendicular angle, because that line was down at 60 degrees, 60 plus 30 will give us a perpendicular angle. So, project out the 30 degrees there. And the exact same, just getting caught in the paper there, here. Okay, and the exact same, this is coming at 60 degrees, so I can do the same down here. Checked out 30 degrees and 30 degrees. And if I have it done here and here, I can do the exact same on this side and this side. Okay, because that was at 60 degrees, so I'm just going 30 degrees the other way. And then here as well. And there we have it, okay? And in all of them, what I'm going to do is I'm going to mark the 36. I think it was 36, yes. And take this distance. Right there, like that. I'm going to mark it on each of them, okay? Just do it on one of them. So, that one done there. Once I've it done on one side each time, I should be okay. And then finally on this one. Because what you'll find is, it's working out quite handy for us. This line now and this edge are going to be parallel. So once again, back up at 60 degrees. And do the same with this guy over here. And then 60 degrees this way. And then 60 degrees this way. And now at this point, it is simply a case of heavying in all the detail that is relevant to me. Okay, so there's those two 60s. This one. This one. Okay, now I can go at the 30 degrees. You can see it's all kind of matching up. Okay. Project it around 30 degrees this way. And the exact same here, 30, 30. And there we have it, guys. There is the 6 faces, and once again it's simply a case of join the diagonals. Okay, that was just showing you guys there another way of basically developing out our hexagon, okay? Or sorry, our hexagonal prism, okay? Sorry, a bit of a tongue twister there. So we had the trampoline base at the bottom, and in this case I folded out the sides, okay? Another way, as I said, we could have done it was where the sides were all attached onto each other and we just did the trampoline at the bottom. That is probably an easier way, but it's good to show both methods and to know how to do both methods. It's very simple, guys, from this point here, as we could see. Now if I was accurate, and that should be accurate, you can see that they all match up together, okay? So if I was to go to every one of these, you can see that they're matching up, okay, because they all have the same height. Therefore, when they fold back together, okay, when they all fold back together, they'll all meet at the exact same height. Therefore, we know we're accurate. Just put those in. This is just demonstration purposes, and as you can see there, it's all matching up. Okay. Hope you found that helpful, guys. Obviously, that bit there is not in heavy. All right. Hope you found that helpful, guys. That is the question complete there. Okay.